Hello, this is Toby, and I'm once again sticking my oar in before the main episode starts to bring you this time some news. As you will have noticed if you're a long-time listener, we don't accept any advertising on this podcast. There's no Squarespace or Harry's Razors or anything like that. I mean, we don't even advertise ourselves really, and we're lucky that we don't need to because we are funded by the European Commission very generously. But I will flex my editorial privilege on this one occasion to let you know the interesting fact that Science for Policy is no longer the world's only podcast focusing on science advice. Hurrah, there's another one. It's created by our friends at INGSA, the International Network for Government Science Advice, and it's called Horizons. If you think you recognise that name, then you're probably right, because what they're doing with their podcast, at least to start with, is republishing in handy audio format recordings from their past events, which you might have seen elsewhere as videos or indeed at those events under the same title, Horizons. So far, I think there are 7 recordings to listen to on their podcast stream. They're doing the Netflix thing of dropping the whole batch in one go so you can binge listen if you want to. And there are, as you would expect, some really interesting people and topics on the list. So I am delighted to welcome INGSA to the podcast world. And if you, dear listener, enjoy this podcast and you still have some time in your day to think more about the kinds of issues we explore, then I enthusiastically recommend looking up INGSA Horizons wherever you found this show, or on the INGSA website also. But don't do that before you finish listening to today's episode right here, because it's a good one, as you'll shortly discover. Here's the cello music. Hello, welcome once again to the Science for Policy podcast. My name is Toby, and today I'm joined by Professor Silvio Funtowicz. Professor Funtowicz is a philosopher of science, originally a mathematician who has worked in Argentina and the UK, did a stint as a policy officer at the European Commission, and is now a guest researcher at the University of Bergen in Norway. In Science for Policy circles, he is very well known as one of the 2 parents, along with Jerry Ravitz, of the concept of post-normal science, which has been hugely influential, it's fair to say, in the study of the relationship between science and policy since the concept was originated by Silvio and Jerry in the 1980s and 1990s. So welcome to the Science for Policy podcast.
Hi, Toby. Thank you for inviting me and for your interest in the subject work we developed with Jerry Ravitz during the 80s, actually, at the University of Leeds in England, Yorkshire. I think you have some knowledge about the place.
One of my alma maters, yes, indeed. I did my master's there a few years later. In fact, in the same philosophy department. Happy days. So tell me a bit about the work you were doing there, developing this concept of post-normal science. Before we get into the practical side of things, like just fill us in on the basics. Where did the whole idea come from?
Really, the origin is, in a sense, science advice, although it was not called that in the 80s. We were talking about science for regulation, perhaps. It was, the research that was done in order to regulate risks. There was science for the legal aspects, there was science to establish safety limits and all that type of research. And our interest was mainly on uncertainty, because one of the main debates about the technological development on the early 80s, 70s, it was the development of civil nuclear power and other very big complex systems like petrochemicals and those type of things. Okay, so our first work was just to explore the validity and legitimacy of the quantifications done in risk analysis. So what we did is to start trying to elucidate notions of uncertainty. We wrote a book that was published in 1990 on uncertainty and quality in science for policy. As you see, we are already focusing on science for policy. And in that sense, I want to clarify that most of our work has been in the context of science for policy.
Right, so how did that work lead to post-normal science?
One of the things we did, and this is the immediate precedent of post-normal science, was to try to look at different contexts in which these calculations, these predictions were made. Okay, and then we realized that it was not always the same. So we started talking about different contexts in relation to two dimensions that we consider very important when dealing with science for policy or policy-related research. We need to analyze those processes and products delivering inputs in terms of the uncertainties of the systems under study and the stakes involved. How important and for whom? And these two dimensions are not independent. I mean, if something is important for someone, there will be research done in order to create uncertainty. As you know, there were in the 90s and later papers and books about the fabrication of uncertainty related to tobacco, for example, and a big pharma, agro business, and so on and so forth. And lately, the last ones on climate, right?
Yeah, so this is interesting because normally in the paradigm of science, we like to talk about moving from more uncertainty to less uncertainty by doing research. So research closes down uncertainty gradually, right? And then I guess at a theoretical limit, when you've done all the possible research, which of course is not something we can actually do in practice, you eventually get to zero uncertainty. But now you're talking about going in the other direction, because you said, look, when something's important, we do research on it, and that generates more uncertainty.
Yes, exactly. That's very interesting, your point. When we talk about uncertainty, it is important to elucidate. And meaning, so I don't want to go into detail, but the idea is that there are different types or sorts of uncertainty. So you have at the level of technical uncertainty, you have methodological uncertainty, and you have epistemological uncertainty. This is quite different domains. They have to be handled or managed in different ways. They are not the same instrument, and you could go from physics to other and look how each discipline and field of knowledge has developed their own mechanisms to handle uncertainty. But the idea that you mentioned, that you can eventually arrive to the truth by reducing uncertainty, I think it's a kind of linear view. The whole thing is more complex. And I'm not saying more complicated, and I'm distinguishing between complicated and complex very clearly. Is that if you advance knowledge, you have progress in knowledge, you will create uncertainty at the same time. And I would say that science and technology are the biggest creators of uncertainties we have, in a way. It's not just a finite container. You advance knowledge and then uncertainty is reduced. No. Lately, you are aware that people have started to talk about the ignorance we know and the ignorance we don't know. The unknown unknowns. So instead of reducing uncertainty, we are becoming more aware about how uncertainty works. And at the same time, everybody has to realize that there is a game to be played with uncertainty. So at the beginning, they were all a subject for experts. Then it became a subject for those who were opposed to certain type of technological development. And then has become a big political game of uncertainty. And in that sense, I would argue, boldly, that uncertainty is not a problem for science. It's a problem for politics. As a scientist, I started as a mathematician personally, and then entered into philosophy of mathematics, things like that. Uncertainty, why should it be a problem? On one hand, it's a challenge, and it's what makes the whole doing science, doing mathematics interesting, and that you have to abandon this idea that you can predict and you can control, which is the big ideal of modernity since Descartes, onwards. And so what we found is, starting, as I say, from the debates about quantification in nuclear power, and mainly on work done by others, like Alvin Weinberg. He coined the term transscience to describe problems, policy problems, that even if you can express them scientifically, you couldn't solve them scientifically. People believed that if you can express a problem scientifically, you can solve it scientifically. And he illustrates that that's not true. So we started to explore these type of problems that has certain features that may not amenable to solution by our scientific method. Let me just simplify. So we characterize these problems, what we later called post-normal science, but as what are the post-normal conditions?
Yeah, so, good. If we're getting into the features of post-normal science, then perhaps I can ask you to clarify something which I have not quite understood in the little that I've heard and read about this. I need to do that directly or just kind of take it as a framing for what you're about to go on and say anyway. It's about whether these conditions are new. Because you talked about science in a post-normal world. Well, okay, post-normal suggests that things were normal and now they're different from that somehow. So is there a new class of problems which we need this new approach to tackle? Or is it more that some problems have always been this way and we've only now discovered the techniques that we can use to understand them?
Well, that is, we have a nuance here, right? And I don't want to bore people with ontology and metaphysics, because at the end of the day, you can ask, suddenly things became complex, or it was always complex, but we looked at those things from a simple perspective, right? I prefer not to enter here, although, as I say, I love discussion about truth and about ontology and about metaphysics, right? For the forefathers of the scientific methods and the modern state, the European modern state, Descartes, Galileo, Hume, the world out there was a mechanical, instrument. So there was no uncertainty. It was simple. It worked. The uncertainty was the result of our passion. Hume, the idea that the reason and passion. Galileo called it secondary qualities, those things that are part of our perceptions. So instead of going into, as I say, heavy philosophy, let's go from a more practical point of view. Post-normal science, you could say, is not new. And it didn't appear just like that. It didn't emerge like that. But was part of a process, a historical process, and a change in perspective. Let me remind you, until, let's say, the beautiful 50s, the nostalgic 50s, when science developed from small science into big science, mainly moving from Europe to America. And you had those very big techno-scientific projects like nuclear energy in the States and space exploration in the Soviet Union, right? But by the beginning of the 60s, the mood started to change, right? And this is very important. Perhaps you're aware that the President of the United States, when he finishes his mandate, gives a farewell address, And in 61, it was Dwight Eisenhower. He was the top general of the U.S. armies during the Second World War and a Republican. and he was president of the US. He created what we called the industrial military complex. But in this farewell address, it was amazing because he starts by saying, what are the drawbacks? What are the problems with this? And he says something very important and relevant for your question. He said, as we have scientific research and the scientific endeavor as very important and fundamental, we have to be aware of a problem that public policy might become hijacked by a techno-scientific elite. Those are Eisenhower words, and he cannot be confused by a troublemaker or, anarchist or whatever. So he already 61. And then in 62, we have also Rachel Carson's The Silent Spring, where she reports, denounces, whatever you want to call it, the pathologies of technological progress applied to agriculture, right? So you see, and then of course, in the 70s, we have Alwyn Weinberg, we have the emergence of popular epidemiology. The beginning, it was called, in a politically incorrect way, housewife epidemiology, where communities and people started to do what it's now called undone science, the type of science that was not done by official and accredited experts. So these are the sources of post-normal science.
Okay, I hear what you're saying. So then, having diverted you, perhaps I should allow you to come back to what I think you were intending to talk about anyway, which is under what circumstances is post-normal science useful or applicable?
So, in a sense, we identify, looking at the examples, at the cases, we identify 4 conditions that we call the post-normal conditions that define a situation in which we propose the post-normal science, as a complementary, not to eliminate the others. When I mean other problems, that I'm talking about normal science, applied science, the expertise, engineering, medicine, all that type of things. So this is complementary. It's not to replace them. And again, remember, we are talking about science for policy. Some people say, do you want to do a focus group to establish the laws of thermodynamics? That's nonsense. Okay, so post-normal science has never said that, and it's not saying that. So we are talking about special conditions. What are those conditions? Well, the first is that facts are uncertain. The second is that there is a plurality of value systems involved. The third is that stakes are high. And the fourth is that decisions are urgent.
Right. And I think we can all fairly quickly and easily think of examples of issues recently where those 4 conditions have been met, such as the COVID pandemic, very obviously.
Or beyond climate, or even a bigger problem or challenge, which is the sustainability.
Yeah, sure.
So all of these share these conditions. And now, what we are arguing, and we argue, is that there is a role for science, normal applied science, of the disciplinary type. There is a role for the type of skills and expertise and values brought by professions like architecture, engineering, and medicine, which are not strictly speaking disciplinary science. And there is a role for something else. What we argue is that in those cases, precisely because of the urgency of the decisions. So with COVID, we couldn't wait for the science to apply the method, come back with all the quality assurance mechanisms and the robust publications and find. We have to do it on the basis of what we knew or we thought we knew in the context in which we were, of urgency. So that is the first type of insight. The second is that even we put into brackets the ideal of truth. So, because some people say it again on post-normal science, we threw away the ideal of truth. No, we put it into brackets for the type of problems we are discussing, right? Okay. And in that sense, we said we should focus on quality, which is fitness for purpose. Quite simple.
Right. So, I mean, I appreciate the basic insight. So the idea is that in these special circumstances you're describing, finding the quote-unquote truth is not going to be possible or even helpful because of the time pressure and the conflicting values and the high stakes and so on. Okay, but then when science replaces the goal of truth with the goal of fitness for purpose, how does that help? I mean, who judges that? Who decides the purpose in a contested space?
Right, exactly. Yeah. Who defines purpose? And thus, the way we make operational this definition of quality through what we call extended peer communities. So the extended peer communities are the institution, and by institution I mean formal and informal, right? That evaluates quality. So it's an extension from the traditional mechanisms of peer review in disciplinary science. But in disciplinary science are the people who studied with you the same things, that publish in the same places. So it's peer review and refereeing. It's your colleagues, your epistemic community using more complicated works that judge quality. Of course, but we are talking about the development of knowledge, what it was called curiosity-driven science. But when you are no longer in that context, there are other people who are who are judging quality. Even in disciplinary science, your funders, right? The state, if you're working for government or the military. So you're extending the community of evaluators of quality, right? So it's very simple. Post-normal science is not a new normal. Post-normal science is not a new method in the Aristotelian or Bacon, how they call the organ. It's not. And it's not a new paradigm, or at least we don't believe it should become a paradigm. It's some insights that can help problem solving under special conditions.
Yeah, I get what you're saying, but I don't know if this is because of modesty or for kind of tactical reasons, but I think you are maybe downplaying the breadth of scope that post-normal science claims for itself, or that people claim for it. And I don't mean that necessarily as a criticism. I mean, we all know, to the extent that it's become something of a cliche, that so many of the big pan-societal existential problems which we face now, like climate sustainability, like our food systems, our health systems, you name it, these big issues, it's almost a truism now that most or all of them do meet the conditions you've outlined. Contested values, high stakes, uncertainty around facts,
yes.
Right? And these are all the areas where science is expected to deliver the answers, or at least to contribute in a very major way to those answers. So it's all very well to say post-normal science is limited to specific conditions, but come on, if those conditions are almost universal, that's not really a limit.
Yes, in that sense, for us, it was important that some people involved in science advice, to say promote it is too much, but they try to, diffuse this idea. Peter Gluckman, for example, we owe a lot to Peter Gluckman, especially in the international arena on academic and policy circles and things like that. No?
Yeah, so I wonder what your view is of that. Because I do get the impression, like you, that in the academic community, these ideas are quite well established. And maybe in the science advice community too, you're right. As you say, thanks to people like Peter Gluckman and, of course, yourself and Jerry Ravitz and others, maybe it is also now becoming rather more recognised and starting to replace or complement the old school Enlightenment ways of thinking. But then beyond that, you've got the community of the recipients of science advice, so policymakers, politicians, and also beyond that, the public. And it strikes me that those groups of people still often see science in the more traditional way, as like having the potential to deliver clear and true answers to difficult questions, right? And to lead policymaking in that way. How do you see that?
First, it was, as I say, climate, where some of the people who started the research on the subject said, well, we have here a post-normal science. But people use post-normal science in very different ways to apply it, okay? And in that sense, one thing is what I can tell you about post-normal science as one of the creators, and I know that Jerry more or less feel the same as I do. But there are people, that they are using the ideas and developing methods and ways. When I work in the Commission, I participated in many meetings, work groups, task forces on science for policy. I have to say that you know how these things work, where all different type of interests and come into play. At the end, there are compromises arrive. But I participated, and you could see a development, progress in that. And you say, oh, today, participation or even citizen science or whatever, is obligatory almost. You can have a tyranny of participation, But when I went to work for the Commission, it was not the case. So when I went, and you can look at that work that I did in '89 with Bruna De Marchi and other people on precisely how to introduce uncertainty against what many people thought, that if you tell people about uncertainty, you will lose credibility and trust.
Yeah, okay, that's interesting.
We are very proud with Jerry. The reach that post-normal science had outside the institutional academic setting. That, there are, more than enough papers on post-normal science, but it is the great literature, the websites, the reports, done by environmental justice movements, and so that makes us proud. And in places in Latin America, in a sense, post-normal science is a continuation of the creation of ideas about action research, okay, in Africa and in other places. So I think that for us, this is very important. And the way they elaborate our ideas and insight, which were in a sense European, sitting in an office, in a corridor in the University of Leeds. And we see how these things are taken and elaborated and reconstructed in situations of conflict, not in situations hygienic, not in nice situations, but in really a painful situation. So for us, I think for us, this is a big success.
Yeah, that must be gratifying, especially when one of the insights you had was exactly the importance of widening your community of peers beyond just the academic community when you do science for policy. To see that very insight itself extending widely outside academia must be nice.
Yes, but part of your question was related to this. You can argue about participation, diversity, inclusion, all those terms, in terms of fairness. moral reasons. You can argue in terms of politics. It might be efficient. But we argue also that it makes better science. And I think this is something that many people miss. And that has to do with complexity. Because complexity is ambiguity in a simple way. So there is a plurality of perspectives that are legitimate, but cannot be reduced to a single perspective. Oh, we have physics, theories in physics are that way, light, particle and wave, and so on. So they are ambiguous. And we know that if we look at one aspect and look at the other.
And I buy the general idea, but I think it's slightly mischievous to bring in physics because physicists find that kind of thing unsatisfying, don't they? I mean, the ambition is always to reduce the ambiguity. Either there's a hidden variable which we haven't found yet, or else you get this kind of shut up and calculate attitude where you're supposed to just not think about the plurality of interpretations
Yes, well, but that was Einstein's program. He talked about hidden variables, but not all physicists agree on that.
True.
And if you look at what's going on today when you go to down, there is such a big diversity, of opinions. That's something that the multiverse and things of that type wow. Right. And, I think in one of our papers, early 90s, we said that cosmology was one of the early versions of post-normal science because you couldn't separate astrophysicists from bishops or theologians.
Yeah, I don't know. I mean, we probably shouldn't go down this rabbit hole. I'm not sure I find this. I don't know. I'm not convinced. I think even if there are some physicists who might say, okay, we're not going to find the grand unified whatever, and there are multiple perspectives right at the bottom level fundamentally, and we have to find some way to live with them all without reducing them to something simpler. I bet even then if someone tomorrow found the hidden variable, they'd all say, oh, thank the Lord, that's a relief, because wow, we hated that fundamental ambiguity.
Yes, it is possible. I mean, since Galileo, the instrumental view, is important and in that sense. But you have Nobel laureates. There was a big debate between two of them. Anderson, for example, has a beautiful paper against reductionism, and you had someone whose frenemy, as they call it today, Weinberg, who say exactly the opposite. In praise of reductionism. So we'll see. I mean, perhaps it's all like Hitchhiker's Guide to the Galaxy, and eventually we'll come to 42. But I don't know. And to tell you the truth, personally, I'm not so concerned about that. I would say that it is important because of the challenges that we have, returning to policy advice. Okay? I would say that something I'm saying quite often these days, and it is the following. First of all, there is a cost in abandoning ideals of prediction and control. And the cost is that having big social experiments. Think about COVID, or even in climate, or we have big social experiments. Now, our system of governance, institutions, legal system, constitutions, they're all, in a sense, based on science, right? So to change from an idea that, well, we are reducing certainty, we'll achieve knowledge, we'll produce the truth, and that truth is almost equivalent to the good. And even going back to Pythagoras, the good and the truth and the beauty, that was the whole system. It then divided, but doesn't matter. The fact is that, okay, to change. The problem is not to experiment, it's how to do it with credibility and legitimacy.
All right. So with that in mind, what are the practical implications here for, let's say, policymakers grappling with a big complex challenge like COVID or climate, where they feel that the pull to turn to science and ask, how do we follow the science? What do we do? What's the post-normal science answer to that question?
I would start by putting my hands in front and saying, well, this is a serious problem. There are a lot of things at stake. But if I can suggest something, I would say diversify your source of knowledge inputs. And that was not done. As you know, in most cases, the advice was reduced to some biomedical elite, modelers, and economists. Because in most places, especially in Europe, but in most places, COVID problem was framed as saving life or serving the economy, which is a very reductionist way of looking at it. The other was the problem of follow the science.
Don't get me started.
And on that, there are many different opinions. I just want to mention an interview that was reported by the Times Higher Education to David Spiegelhalter, which I'm sure your audience will know, expert in statistics and risk, and a part of the experts advising on what to do. He said, that awful phrase, follow the science, because it conveys the idea that if you know the science, you know what to do. So, and you can say, oh, that's the politician taking advantage of the scientists to justify and whatever, and also to shift, the blame. But on the other hand, in the UK, you had example of an alternative advisory group of experts, right? And you look at what was going on in Sweden, or you go in other places, and you see that follow the science is everything and nothing. And even to the point where you had epidemiologists, modelers, discussing publicly. And I think this is very positive. There was an interview also recently, I'm using, in the Corriere della Sera, which is one of the main newspapers in dailies in Italy, and they interview an immunologist, one of the top immunologists, and he said science has to apologize to the Italian people because science didn't speak with one voice. Okay? Of course, you can say it's nonsense, but on the other hand, and part of what you said about decision makers and others, they expect science to speak with one voice. Okay?
Yeah. And I suppose this might be part of the reason why they tend to turn to your biomedics and epidemiologists and modelers rather than social scientists or philosophers, say, because the answer they expect is a simpler and more unified.
Bravo.
Yeah.
But there are nuances here, very important here. And the nuances are the following. That in the case of COVID, what we found is that even immunologists, virologists, hard scientists involving controversies and saying publicly and without being shamed that there are things that they didn't know. So, and that I don't think influences the trust people have in science. Okay, at least according to the research done on that. And your point about social science, and I would add humanities, is important, very important. What are the effects of confining people in houses that are not prepared? And that was a problem we had with risks. Bhopal is a great example. You had a cloud, a poisonous cloud, and you tell people to close themselves inside. They don't have houses to close themselves inside. Okay? So who studies those things? Who advises on those things? The other thing is, many households have a long history of domestic violence. Who is the expert on that? Who advises on that thing? Then there are the psychological effects of a family being together, or people being together that they don't want to be together. So you have many aspects. A lot of things, I think, were learned on the spot by the frontline doctors and nurses. And who was in charge of using that evolving knowledge? Nobody. So that's precisely the point. And I think in that sense, COVID is very, very important. And we can use it, the positive and the negative experiences, to push for different ideas about science advice and knowledge input. Post-normal science, as I say, and we are very proud of it, has pushed the idea that not only that science doesn't speak with one voice, and that's not bad, but also that knowledge doesn't speak only the language of science.
Yeah.
Because we, in our human history, many big challenges, crises, have been solved by other types of knowledge, practical knowledge. The problem of longitude, solved by a Yorkshire clockmaker, Harrison. If you go to Greenwich, I tell my students to go to Greenwich Observatory and see the Harrison clock still working. And that was a problem that was not solved by Newton or fellows of the Royal Society. All the big ones were involved because there was an award by the British Parliament. And they didn't want to give him to Harrison because he was not a scientist. Okay, so let's abandon this. We cannot afford to lose knowledge. And you can see that that is happening.
Are there areas of science advice where we're getting it right?
In IPBS on biodiversity, you can see an attempt to establish a kind of choreography of knowledges, that each of them come with a different cosmovision. Because we are talking about biodiversity, we are talking about socio-technical ecosystems, and so on and so forth. This is something that we are very proud to support and say that some of this idea, conservation science, is almost all post-normal today. You see? So I think, and perhaps we have to finish soon, and if I didn't touch something, you can tell me. But I would say that these things are very important for the future and for the present. I'm a nowist. It's now the problem, it's not in the future. I want to be clear. The solution is not in the sky, although a lot of money and effort is put into that. I think it's a new version of the idea. In the past we thought that the future for us was in heaven or in the hell. Some people will rephrase it today and say, the future of humanity is in heaven because the earth will become a hell. Well, come on, stop the nonsense. The future is us here trying to live together. And it's not easy because we don't know how to do it. So if I have to give some opinion, let's try to start. Continue to do what you do, but open other doors. Because the trajectory, the path dependency is getting difficult.
Well, I can't think of a better place to finish this conversation or wiser words to leave ringing in the audience's ears. So thank you very much indeed, Professor Funtowicz, for the time and energy you have invested in this conversation, which I've enjoyed immensely.
It was a pleasure, Toby, and people know where I am and if they want more information, I will be happy to provide.
The Science for Policy podcast is produced by SAPEA. We're a consortium of Europe's academies and learning societies, and we're part of the European Commission's scientific advice mechanism. We provide evidence and expertise to inform the work of the group of chief scientific advisors. SAPEA is funded by the EU's Horizon 2020 programme for research and innovation, and you can find lots more information about us and our work at sapea.info. Finally, the rather lovely cello music that's playing right now is performed by Elizaveta Sushchenko, so I shall shut up and let you enjoy the last few bars. Bye for now.